Hey everyone, welcome back to my channel. Thanks for joining us again for another new project. Now, we've had some fun so far building on very strange APIs. We've built tools for my everyday kind of use, but another really great source of inspiration for things to build and things to hone your skills on is, well, our projects that help you every day, that deal with something frustrating, something tedious. I think we all have that in our lives. Sometimes it's fine. I wake up every morning, get some tea or coffee. That's fine. But once you start doing things repeatedly and you don't enjoy the ritual of it, that's when you fall into a realm of automation. I think there's just so much room when you think about what you do every day, when you think about the repetitive things you do. There are lots and lots and lots of opportunities to build something useful. So that is the introduction to our next project. It's something I was quite frustrated about, and I am shocked, I guess. I'm disappointed at the sheer amount of time it took to create something. So let me just move this onto the screen here. Okay. So this was, I guess, a textbook, a practice material. Textbook for family law that I needed to read through. There are a couple of these, so if you look, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of these that I had to go through, and our little study group built these indices. Basically, it's very difficult to reference this in an exam, but it's available for us during the exam. We can look at it, we can use it. So table of contents, of course, helps a lot, but there's no index to this. So ideally, if we wanted to find something out about property and debt under the Family Law Act, we'd be able to search alphabetically in an index. It would tell us what page it's on, and we can jump straight to it. It's a massive advantage in an open book exam. So hopefully a lot of you have similar kind of experiences where you have that opportunity to bring a textbook into the exam room and you want to build an index, or you wish you could build an index. So here is the index that my study group built. I'm pretty sure I didn't work on this one in particular, but this index is 23 pages. It was done manually. Now, in all fairness, somebody does it year to year, so a lot of this, a lot of the keywords were already decided, but somebody went and looked for each one of these, recorded the page number and the paragraph number into it. So let me just quickly go through. Let's go with Certificate of Pleadings, 82R2. What that means is page 82, we're pretty close already. 82R means the right column over here, 2. 1, 2, second paragraph. A Certificate of Pleadings, exactly what we're looking for. So yeah, somebody went through each one of these and updated the reference, because this gets updated every year. So an enormous amount of time was wasted compiling an index for each of these documents. Now, I'm glad we did it. It helped immensely, but you have to wonder how much of this can be done automatically. If we're providing this keyword, I could just Control F custody and find the relevant text. a computer is able to do that much faster and much more accurately. Well, that's step one. Step two is whether we can actually build this from scratch. So let me just give you guys kind of the idea here. I think there has to be some sort of AI library where we can throw text into the AI, into the code, that it will output keywords or key terms in the document. Now, I don't think we'll have something even close to as neat as this, and I don't think we will have the same overlap, like having a team of real life people looking at the document over and over and over will definitely, should definitely yield better results than an AI can. But I'm thinking if we did this from scratch and tried to do this, it would be very worthwhile to save that time, have a computer do 90%, 80%, maybe even 50% of this document automatically and not waste any more effort onto it. And then the second piece is finding this reference. I don't think it will be as neat as this one. I don't think there's an easy way to count paragraphs. There probably is. There definitely is. You can kind of parse through the document. You can find out whether the text you found is what page it's on, whether it's on the left side or the right side, and then you can kind of cut the PDF to try and figure out how many paragraphs it has gone down. I think that's a bit ambitious. I think we can just find the page number, maybe find the location of the text. So I think that'll be much easier. Okay, so again, the plan is to find some AI that can spit out keywords, and we don't need AI, but some sort of library to read through a PDF, find the keywords we're looking for, and then find out where they are in the text. And I am very curious to see if we can get even 50% of the way here. Like how good will it look when compared to this document? So I'm going to do a bit of research, and then we're going to jump right into coding it. Okay, so I did a very, very quick Googling session. I had this open already, so I think this is a pretty good post by lessthan.com, November 21st, 2016. It compares a couple Python keyword extraction results. So they went through a couple of different posts, and then they give you the examples here. Rake has these short phrases, I suppose. Test markers turn green and red, continuous JavaScript test execution. It's actually kind of cool. I wonder if we can make summaries out of it. You can definitely kind of retrain each of these for your purposes, but this one gives kind of, well, I mean, it's a phrase. It's almost a sentence, but you can figure out what it is, the gist of it is, what they're trying to do. So that's very interesting, but unfortunately, I don't think that's what we're looking for. TF, I assume that's TensorFlow IDF. I don't know what IDF is, but pretty simple. One word keywords. One-word keywords. And according to this, it is just frequency of words found in other documents as part of the score. So I don't think it's just counting the numbers. I hope it's not. It's probably doing something a little more sophisticated, but frequency is interesting. Where I think where I think we'll have the most success is test rank. So that's probably where I'll start off with. We have these kind of 2-word phrases. This one's all 2-word phrases. I think they will pick up 1-word words and probably more than 2-word phrases. But you see, this isn't capturing a phrase like rake is. These are keywords. Vanilla bootloader, custom bootloader, that's important. And so if we jump back into a family law, like 1 word wouldn't work very well. Proceedings versus other proceedings. Child, Family, and Community Services Act. Family law, child will show up so frequently, as will family, harm, law, federal legislation. Those will show up so frequently that I think tf-idf is not going to be helpful. The keyword of child, family, that's not going to help. We need a little bit further in, like child, family, and community versus let's say divorce. You might have divorce forms, divorce orders, divorce proceedings. You need that second word. And finally, I like the phrases are really cool. I just don't think that will be helpful here. The next piece is, of course, searching up text. So I found this one, which I'm actually surprised it does this. PyMu-PDF. I wonder if that's how you actually say it, but this library lets you search for text. That's not surprising, but it delivers a list of rectangles. Okay, so rect. And it gives you 4 floating point numbers. What that means is it's creating a rectangle. It gives you this point, this point, this point, this point, so you can form the full rectangle. So top left, top right, bottom left, bottom right. And in that case, you can kind of figure it out. I think what we can do here is, let's say the word you were looking for was that certificate of pleadings. You'll get this box, and from that coordinate, you know that it's on the right side, and from the x coordinate, you'll know that it is on the right side, and from the y coordinate, you wouldn't be able to tell what paragraph it is, but you can maybe create a new kind of notation. So here, well, we're not bound by the notation that my colleagues, my classmates used. I was not a particular fan of this anyways, but we may just use the coordinates. Find the center of the rectangle, so middle of the x coordinates, middle of the y coordinates, you'll have it dead center, and then just put the coordinates down. Page 82 coordinates, maybe average it out so that this is 1. Sorry, the page entirely is 1, and the page width is 1, the page height is 1, so we normalize it. So as soon as you cross 0.5, you know it's more than halfway. That may not work. We'll see how it goes, but it's looking pretty good. People have already kind of given us the pieces here. We'll use the text rank algorithm, and then we'll use this PDF searching library. Okay, so we're gonna head straight to work then. Hey guys, I just had to stop the video, slow it down so that you guys can take a real look at this. We have, of course, this section right here. This is the text rank algorithm, and this rakeNLTK is the rake algorithm, and both of them do the same keyword extraction thing. But I just wanted to show you guys how it looks. What happens afterwards. So let me just put this over here. This one over here as well. Okay, so what am I doing here? What I'm doing is I'm concatenating all the pages together because the keywords in one page, so if we look at just page 13 in the document, we're going to have fairly general keywords like family will show up a lot, children, words that are very general but won't work very well over the entire document. But if we start adding the whole document together, the algorithm can go through all of that text to figure out what is the keywords in the overall document. So family is not going to be a keyword, but family law or family court or something like that, those combinations will hopefully become the keywords. So for now, we're just doing pages 13 to 15. It's not going to be all encompassing, but it's just a demo. First of all, keywords with text rank. And look at that. Those are our keywords. And these are really good keywords. They haven't pulled out the thes and a's and ands, the very basic words. They have pulled out family, resolution, following, follows. I think that will disappear once we really look at the document as a whole. But some of these are really good. Court, agency, family, claims. These are things that we want to pull out. I notice that there is a problem with the document. We're gonna get zhins, t's. These are like the end pieces of the word. So if you remember the document, they sometimes have the new line break. We have the first part of the word, and because they want to justify the text, the second half of the word continues on the next line. I hate that, but we will think of a way to deal with that later. But clearly this showed up more than once. So did a nap in nap. I'm not sure what that is supposed to be, but yeah, so text rank gives us pretty good keywords, and then we can take a look at the rake keywords. Okay, so let's run this instead. Remember, this is over 2 pages, but rake has these phrases, remember? Family violence may impact. That's starting to borderline a phrase, but family law dispute. That's really good. 2019 Divorce Act. I wish I didn't have replaces, but 2019 Divorce Act, that's a huge keyword here. They have all these smaller ones too, of course. Reasonable instructions, and parties, vehicles, property. That's keywords. Probably if I was looking at an isolated sentence. So if you can imagine a really important sentence is, we want to look at how many vehicles, how many properties, what kind of savings an individual has when we go through a divorce. But in the grand scheme of things, in what I'm trying to achieve, those aren't particularly helpful. So I'm still juggling what the 2 most useful pieces are. But the other thing I played around with is the summarize feature for text rank. So let's run this one now. And so it takes the 2 pages and it summarizes. Here, I've done a ratio of 0.01, meaning 1% of the entire document. So for every 100 words, the computer can put in 1 word. And so section 5 of the FLA requires parties to provide. That sounds quite realistic, actually. Just based on the keywords, what do you need to provide? Probably information about your vehicles, your resources. You're probably going to need to provide, reasonable instructions. So, I don't think that's a bad summary. There's no way if I told the computer to reduce it down to 1%, it would have the ability to list all of the things required. But this gives us a pretty good idea. But let's bump this up to like 10%. That's not as impressive. Resolution through a family dispute resolution, inform the client of family justice, inform the client of the duty of the parties, advise clients, sets out the duties. Actually, now that I look at it, that's not bad either. And if we go 0. What's a reasonable summary? Probably like 1/5 the size. We start getting this. So this is actually looking a little bit like the phrases in TextRank. So number one, I think that is super cool. I wonder how we can use this. I wonder what other algorithms in there are. I'm sure you've seen kind of the Reddit bots that summarize news articles or posts, and they're much better than this, but I'm sure they're doing some sort of similar calculation in the back. But the reason why I was going with this in the first place is because I was thinking if I summarize it to, say, 90%, if I summarize it to like 90% of the text, we get most of the text here. A lot of it. It probably took out a lot of those and so on, but maybe if I summarize it and then ran the keywords, it might be able to pick up better sets of keywords. So a lot of this seems to be very finicky. It's going to require a bit of adjusting, but I'm hoping that I'm going to combine one or two of these. Rake might have these kind of phrases, but maybe the keywords will be able to pick out the keywords in the phrases and basically give us a better result. So for the next little while, what you're going to see is me kind of going back and forth trying to get the right combination. And of course, the combination of all the pages will be very helpful. Page in doc. If we combine all of the pages, maybe I don't think TextRank took all that much time anyway. So let's see what happens when we combine all of the pages and run TextRank through it. So just be patient, and here we go. Yeah, so family and families still come up at the top. Yeah, I don't really like these results. They're not all that helpful. They've gotten better, definitely, but I'm missing the compound kind of words. Like varies depending is 2 words, but that seems to be the only one I can spot. Sure, there's more, but immediate plans. I'm looking for these 2-word combinations, maybe even 3-word combinations. So I'm gonna fiddle with that. This is cool. This could be useful, but we may have to go to our backup plan and just use the keywords that that my classmates have compiled over the years. So Yeah, so you're gonna watch me fiddle with this for quite a bit longer. Okay, so I went on kind of a reading spree and was just trying a whole bunch of different solutions out. There are obviously a lot more that we can do on our end. So there are other algorithms, and it seems one of the things that I haven't thought of that I should have thought of is that my text is extremely, extremely long. We're taking a whole 100-page, 150-page PDF document and trying to run text analysis on it. That is a problem because if you look at most of the kind of tools out there, whether it is Azure or something on GitHub, they're looking at shorter, smaller text for you to analyze. They are so the common example that shows up over and over is people want to analyze reviews. They just want keywords from the reviews so that they know there's an error or there's a freeze or there's a bug or something like that. Not nobody, but very few of these solutions are thinking of here's an entire document. Excuse me. Here is an entire document. Try to kind of pull out the keywords from 100, 150 pages or so. So I was trying some of these out, and honestly, if you're trying to build your own, TextRank and Rake were pretty well recommended, but they aren't customized. So if I were to try and keep going down this route, I think what I'd have to do is start tweaking the algorithm. So not even tweaking the algorithm. I don't think an algorithm will solve it the way I'd like it to. So I need some sort of AI or machine learning kind of setup. And, it's not bad since I have existing years keywords. I'd clean up the document, run it against that, and try and get similar results. That is way, way, way too big a project for unscripted coding. So I was looking at commercial tools instead. So I have Azure Tech Analytics. I had Amazon Comprehend, which is over here. And again, both of these had limits on the API. So they have limits like 5,000 characters that you can push to the API at a time. And that's the same problem as before. When I break down page by page by page, it's not picking up the keywords of the entire text overall. And so Amazon, once you log in, lets you look or try out their Amazon Comprehend, just 5,000 characters, but I threw in a random piece of text and I am not at all impressed. Like, look at this. They are highlighting all sorts of things. The agreement, the party's intentions, like all these thes and us, and so much of it is highlighted and underlined that it seems to me, well, it looks like when I would highlight a text, like when I don't understand something, I just highlight like every other word. It's not helpful. Azure doesn't let you put in your own text to try out. So I looking at this, they have the same kind of use case. They're looking at, I think this is a restaurant review. So yeah, these key phrases, there's a lot for such a short piece of text. So I don't think they are doing what I'm hoping for it to do. Surprisingly, IBM Watson, like, it gets made fun of online a lot because it's supposed to be not very good, but this is as close as we can get. Look at this. So I put in, the same piece of text. I think this one's a little longer, but the keywords they pulled out are really, really good. Like, first of all, it's a much shorter list. They didn't highlight every other word. They didn't go down the list and just take out the ors and ands. They have really selected and pared it down. And if you look at the most relevant ones, spousal support advisory guidelines, that is something that I would pick up. Number of mathematical formulas, no, not great, but child support obligations, yes. Duration of spousal support, yes. Objectives of family, I don't know why there's a 50 in there. Divorce Act, yes. SSAG calculations, yes. And then as the relevance goes down, yeah, it's not as good. But, well, some of these are. Year of cohabitation, that's useful, but specific formulas, that's not useful. Court of Appeal, that's not helpful. But again, for such a short piece of text, I am very, very happy with how IBM Watson did this. So that's where we are now. I think we're moving away from getting something off GitHub, doing this locally, to using an API online. And if you look, both Amazon and Azure had it really cheap. I don't think it would have costed more than a couple cents to do this document, maybe $1 or $2 to do all of the documents. Probably a lot less than that, but it's not like I'm not worried about the cost. IBM Watson, I know, had a lot of free tiers, so hopefully we can take advantage of that. The other thing I'm thinking of doing is just pasting a link to the text. So I might have to do this off screen, just upload it somewhere, throw it into IBM Watson, see if they'll take, I think it's 370,000 characters. So it's a long document. But if not, I'll have to sign up for an account. I think I have an account, but I'll sign up for something and see how much it costs. So this is probably the one I'm going to settle on. The other one that I thought was Monkey Learn. I haven't heard of this one before, but it too has a pretty decent result. So yeah, similar to IBM Watson. Spousal support, child support. I just haven't heard of them, and yeah, their pricing doesn't seem to be friendly. It doesn't seem to be, per use loaded down to $1. They want you to purchase monthly fees, so that will probably rule it out. Anyways, we're moving in that direction. We're going to use an API probably. If I can cheat this so that it just does it on this page, that might be a solution too. And yeah, so we shall see. Okay, I am sorry that the video jumps a bit, because I have all kinds of things in the secrets file. So now we have successfully used the API, albeit with a short sample text right now. So the sample text is just overall much shorter than the actual document. So, that is maybe a page or two of text. But what we received back from IBM Watson, is this. So these are really good keywords. I have to stress these first ones: Divorce Act provisions, final orders, variation proceedings applications, making of the order. These are fantastic. And then as we go down, these aren't so good. Parts, substance, court of appeal, not so good once it gets down. So we may do a cutoff based on the relevance. The higher it is, the better it seems, although there are a few down here that are pretty good as well. So the next step is to actually put the full sample to IBM. So let's go back. What we're doing is we have this authentication, we have the service URL, and then we're sending them a text file. So I've sent them this sample.txt file. I've uploaded it in a super secret URL that's in my secret file. And they give you the option of determining how many keywords you want. So I put in 150. It seems like they rank in order of in order of, what do you call it, in order of relevance anyway. So I don't think it's a huge problem if we put in a lot. Maybe that might be too much, but let's say 4,500. I'm hoping for maybe 500 to 1,000 good keywords, but if they're going to sort this out for me anyways, I might as well get it all in one go. The other thing is I get 30,000 free units of 10,000 words. So I get maybe 10 free shots at this a month. So I want to make sure that the first time I do this, it is good when I do the full sample file. So then I can start analyzing the other ones as well. So I want to make sure that in one go they get something that I can work with here. Let's change this. And what's going to happen, and this code is getting really ugly because I just wanted to get this working first, is we'll open up the JSON file again, parse through all of these, maybe do a sort for relevance higher than a certain threshold, and then we'll start searching for the file. So we're getting pretty close. We're getting really close, and let's hope this works. Hey everyone, we are more or less done. I closed out the program so that I can run in the background. It took about 20 minutes to generate this sample output file, but we have basically what we were looking for. And you'll see that it lists the page number, it lists the XY coordinate. I'm gonna just say it up front now. I seem to have messed up the calculation on the XY coordinates, but I will fix that up before I publish it to GitHub. Anyways, let's take a look. This is obviously not a Word document, but if we have a JSON file like this, it's very easy to convert this into a text file, into an application, into Excel, Word. I think the best way to do this is to take this and put it into an HTML file, so you can kind of move it big and small, fit any sort of device. So that will be fantastic. But in terms of usability, I can't say that this is very usable. Right off the bat, ability. That is not a great keyword. That will show up in all sorts of contexts, and you see that it just endlessly shows up in the document. Accuracy, that's not great. Act, that's not great. But it did pick up on basically all of the actual keywords. So for example, if I wanted to look at CFCSA, I am willing to bet that this is in the document somewhere. Yes. So pages 86 shows up, 87, 87, 89, 90. And if we look, remember there's a couple title pages and table of contents pages early on. So with the offset, if we subtract a couple pages, that is exactly what we're looking for. That is perfect. Now you may be thinking, oh, what about all of these notes underneath? And that's helpful. But I think what we've done is we have gotten to a place where we can take advantage of that. Remember that we were playing around with summarizes. So I think if we wanted to put more time into this, we can certainly find child protection services. We know that it's on page 86, and we go to page 86 and generate, probably not 0.7, but maybe a 0.1 or a 0.2 summary right underneath. So if it's something that shows up a lot, like CFCSA, we may want to put down a quick summary underneath. Where am I going with this? I don't think it's half bad. Like if I'm looking through, it's like a dictionary. Yeah, there's thousands of words that I don't need to look, but if it's all in alphabetical order, all nice and easy, organized, hopefully in a shorter document, easier to manage document than this one, we can just scroll through. I don't need to know any of this. I just jump straight to where I need to go. So not bad, usable. We've also gotten rid of the coordinate system. This is a really big file, so my computer's struggling to use it. But the coordinate system, I don't have the left and right. Instead, ideally, I wanted between 0 and 1. So as a coordinate, 0 is on the left, 1 is on the right, 0 is the top, 1 is at the bottom. So say 0.5, 0.5 would be dead center of the document. And something over here might be 0.6 and 0.1, 0.05. And I think that might actually work better than this paragraph counting system they have. Yeah, so workable, and I'm fairly happy with how this turned out. I don't think it's usable, but I didn't expect it to be as good as a human interaction, human-made document anyway. So pretty happy, borderline usable. I think a bit more work needs to be done. There's also a bit of cleaning up for some of the keywords that need to happen bits and pieces here and there where we can polish it up. But let's walk through the document, and that way you guys can see how this all works. We've broken it up into numerous steps. So first of all, we have, let's be able to draw here. We've broken up into steps. So we have the imports up top. What's really important is up here. The secrets. So I have a file which is not going to be on GitHub, and you guys didn't see, but basically it's a secrets file with my API key, URL, and service URL. API key and service URL, these two, are for IBM Watson. As soon as you sign up, it's on your account. You can see it just fine. This URL, this is my own URL. Remember we had that sample text file? I wanted to be able to put it up basically on my public site so it can download, it can retrieve that text file. It's nothing secret, but I just don't want you guys downloading that file over and over. Now, let's just head down a bit. This is step one. Prepare the text files. What this is we use py-mu-pdf. I don't know if that's how you pronounce it, but we open a PDF. And what we want to do is use this entire process to parse through it and get the plain text. So py-mu-pdf has a great function, which is just extract text. We go through each page in the document and then extract the text one at a time. If you're looking at this, what is that? Well, remember we had the line breaks where, say, protection breaks down into protect and un afterwards. What we did was join that together. Now, if you're really smart and you're thinking ahead, this actually becomes a problem when we get our output, because we're searching for the word protection and py-mu-pdf isn't going to find it. It's just going to look for protect. Well, it's not going to join words together to find it. So we may be missing some words because we've joined them back up here. Now, we go through each page and then we just concatenate and add it to this plain text variable. And then in the very end, I write it into a sample.txt file. You guys can take whatever PDF you want and do the same thing. One of the things is that the PDF that I got was fairly nice. It's not a scan, it's not an image. You may need to run it through OCR if you're getting some really old or badly scanned PDFs that don't have text. You know, py-mu-pdf isn't going to be able to extract text out of images. So you may need to run through an optical character recognition software to do this. Anyways, step two. This was something that I didn't expect we had to do. IBM Watson needs to break these down into 50,000 character chunks. It's much better than the 5,000 character chunks that Azure wanted, but 50,000, well, we still had to break it down into, I think, 8 text files in the end. So all this is we go through, we open the plain text, and then we use this to take that first 50,000 characters, and then we erase the first 50,000 characters of plain text. Once we get to the end, we have this catch-all. We just say whatever's left over, we just shove it into the last file, and each time we write it into a new text file that is numbered into which batch. Okay, now, once we have that, we start doing the keyword extraction. Really, we aren't doing anything ourselves. What we're doing is just getting these 50,000 character batches and giving it over to IBM to read. And so we open up each individual file. And then over here, with this right here, And I'm sorry, my hand is just in the way here. In this document right here, we pass it into IBM. And again, we have the text. We've kind of limited it to the number of keywords to 4,500. That's fine. We get a result. It becomes a JSON file, and then we write it into these separate JSON files right here. Okay, next piece. You know what? I don't think this writing on the screen is doing us any favors here. So I'm just going to use this cursor. Hopefully you guys can see. Now we run through each of the JSON files, and then we get the keyword list. We build a list of keywords. And what we're doing is we're just opening each JSON file. Once again, I'm fixing this up because the apostrophes have this /U 2019. There are probably other characters in there, so you can kind of keep polishing this up, but we append it to the list. And finally, we do the search. This is where I thought it would be simple, but it did take a little bit of math. We open the PDF. For each page in the document, we search through all of the keywords in our list. And for each rectangle it returns, meaning each result, we try and parse it so that we get a page number, we get the XY coordinate in this normalized fashion. Now, don't look at these two. Apparently, I screwed up my math. That's why we have all these funky numbers, but I will obviously fix that up afterwards. We append it in, we append it to the keyword into the locations, and then we set the keyword as a key and the location as the value. So we create this giant JSON file, which you guys have seen so frequently. I think it is pretty straightforward. I think there's a lot of opportunities to tweak here in the keyword extraction. That is the key, and we've kind of just let IBM do all of that. But if you're really trying to model it after you really get it polished, you can throw in your own machine learning engine here. Just run it through, build something very customized for your purposes. So that's all. That's all there is to it. So we tried to make this document. We got this JSON file instead. And yeah, happy indexing.